identify whether the workload inside is a container or a Kubernetes application, and strips these VMs of everything which is not needed, everything which is legacy. And this allows us to start these containers in a hypervisor, so it's firmly secure, but it boots them at the same speed as a container platform in less than 1 second.
Okay, thank you. Another question that's come in, I guess related to that, is does NodeWeaver, can it be installed as a virtual machine, or does it need a physical machine?
Well, NodeWeaver in itself is designed to run on physical machine because we take advantage of every hardware platform. One of the things that NodeWeaver does when it boots the first time is that it does a sort of inventory of everything that the machine can do, and it creates a custom version of itself designed specifically to run on that machine. However, we know that there are many customers that want initially to test NodeWeaver. They want to, let's say, do a trial of it without committing to actual hardware. And for those, we have the ability to run also in cloud environments for example, we have a partnership with Packet, which has been recently acquired by Equinix, but we can run also in other environments like VMware or VirtualBox.
Thank you. Jeff, the next question I'm going to turn over to you. The question is, what are some of the hardware requirements you're seeing in the edge, such as backroom storage areas, kitchen areas, or outside?
Got it. So yeah, what we're seeing is we, like I said earlier, we do kind of offer from a hardware architecture piece, kind of the small system. So maybe I'm a small boutique store, as an example, or maybe a small restaurant, and I don't want I don't want to have a PC sitting at my desk that's doing all this stuff. Maybe I want a fanless environment, something that's quiet, because this is going to be underneath my cash register, as an example. So it really depends on the environment that I'm putting this in. But it seems like our workhorse systems that seems to be gaining most of the traction are two things. One is, if you ever go to the Supermicro website, you'll see in our IoT and embedded space a system called the SYS E403. The system itself seems to be kind of the powerful workhorse because it offers multiple GPU-based options, different Intel-based options, depending on the workloads I want to run, all the way from low end, all the way to 24-core plus. Connectivity, kind of having the ability to do small, maybe 1 gig ports, all the way to higher end NIC ports that even could be using fiber connectivity, and LTE or future 5G-based connectivity. And that element can be placed either in it has to be kind of a controlled environment, whether it's a back room of a storage system or whatnot. But we also can put this into an IP65 cabinet that can go into maybe a heavy moist environment with rain or moisture, and also high temperatures from a low end and also a high end capability. So the 403 seems to be kind of the powerful workhorse to do most workloads. And then if there's an existing rack system in let's say a big brick and mortar store, and they want to add this type of content, then of course we have rack mount type systems like our SYS 1019 based systems with multiple options, multiple capabilities, and so forth. A lot of people also look at different types of AI based technologies, either from a CUDA AI perspective or maybe an OpenVINO. And of course, with NodeWeaver and our hardware architectures, we support all of that, which is great for the system. Hopefully that answered the question.
Yeah, thank you. Another question's just come in. So how does the storage layer get protection on the single node edge deployment?
That's a very good question. If we try to use, we actually have a small intelligent engine that tries to find ways of reaching the goal of protecting the data with the kind of protection that the customers are requested. In the case of a single node, of course, we would, if possible, use 2 disks, and the system will automatically replicate pieces of data on both disks if you have more USB disk, it will basically create at least 2 copies of the small pieces across all the available disks. If you have a single disk and there is enough space, the system will try to store data in 2 separate locations by using 2 slightly different identifiers. So it's always possible to get back at least 1 piece if one is not available. Basically, when the system is not able to provide enough protection, it will warn the user that unfortunately there is nothing more that can be done, and if possible, add another node or add another disk.
Thank you, Carlo. So the next question I have is, on the outside box, are there any tampering protection put in place, I guess, on the hardware?
Yeah, sorry, go ahead. You go for the hardware, I go for the software.
Okay, from a hardware perspective, absolutely. So in these outdoor-based, secure it and also alarm it too. If someone does try to break in, they go through the locks and all that stuff. It is alarming. It has the ability to uplink to a central management system to say that the box has been opened. We also try to limit, things like USB ports based on what the customer needs are, where you cannot insert a USB and inject, some type of virus or, data gathering element. We also, a lot of these boxes too have to meet, especially in the telecom world, they have to meet certain compliancy standards in regards to the heating, the thermal elements, but also things like, going down the highway and you see a box and that good old boy wants to take a shot at it with a shotgun. It has to protect itself from, firearms and those type of things where people want to kind of destroy the box through gunshots. So it has to protect itself. And we meet most of those compliance areas through NEBs and other certification elements. And it also supports both AC and DC environments as well. Carlo, you want to talk a little bit about your secure aspect?
Yeah, that's one of the nice things of partnering with Supermicro. Actually, we can take advantage of what the hardware provides to us. So we have sensors that basically constantly check the hardware conditions of the locks. For example, we can access the integrity of the chassis. If there's any issue with the disks, we are able to detect tampering or changes of the data as it goes across the disk. So we can basically provide, in addition to the hardware alarms, we can provide a security status for the disk. So we can immediately send a notice that something is not right, let's say, and pinpoint the location of the machine and what has happened.
Thank you. Okay, so we've got one more question that's come in. So in the event of hardware failure locally, would all operations be down until that hardware is replaced?
No, the NodeWeaver is designed to compensate for hardware and software faults. Its primary design has been to do that without the requiring user assistance. So if, for example, you have 2 physical devices, 2 physical nodes, and one goes down for a power failure, for example, or any, let's say, major hardware issue, the other node will have all the data that's needed and will immediately start to activate all the workloads that were running on the other nodes. So in the time of, let's say, the 30 to 40 seconds, the system will have restarted all the services and will be completely operating. This happens independently of the kind of fault. You can have a network cable that is not working anymore. You can have a complete power failure on one of the physical systems. You can have a disk failure or even a software failure. We treat it as exactly as an hardware failure, and we compensate and route across that.
Thank you, Carlo. So as I can see, we're running out of time here, so I think we'll leave it there for today. If your questions didn't get answered, then we will take them offline for you. And with that, I'd just like to say thanks to Jeff and to Carlo for joining us today. And thanks to all of you online for watching the webinar. If you would like to know more, as I mentioned earlier, then please do follow the links in the attachments tab. And we do value your feedback. So as you leave, please do leave us a star rating or comment in the feedback tab, and we'll take that on for our future webinars. So thanks again, and I hope you all have a great day.
Thank you, Carlo. Thank you, Sarah.
Thank you so much.
This live webcast has now finished. Thank you for taking part. A recorded version of this webcast will be available on this BrightTalk channel shortly. Please rate this presentation and provide the speaker with feedback using the ratings button. Also remember to share this webcast with anyone you think should see it using the share button. Today's presentation was brought to you by BrightTalk. As a BrightTalk user, you can find many more engaging webcasts to view at brighttalk.com. You can also manage your personal channel subscriptions, your profile details, and start a webcast channel of your own. If you have any comments or feedback on this viewing experience, please let us know by visiting www.brighttalk.com.